guys, good evening. Can you all see me and hear me? All right. We've started only with I hate biochemistry chants. That's a good note to start the class with, which is gonna be for 4 hours. So uh, let's hope it gets better. I mean, it did. Oh God, I forgot my water. Yeah. Anyways, I'll get my water in some point of time. Yeah, hopefully it will. Yeah, we will complete it. I hope. So that is what we're gonna be doing. I have studied it like. For you guys when I absolutely hate it too. Can I just get water because this is going to be a while and I was so busy making the class I didn't get time to get water. Yeah, just wait for 1 minute. By the time you can join the group and all. Okay, just give me 1 second. All right. Okay, can you now see me and hear me? ठीक है चलो फिर शुरू करते हैं. So see, there are three things about biochemistry, you know, where you get grossly you will get questions from. One is molecular biology, which we have already done. Huh, wonderful. I'm just with water. Thank you. Yeah, so there are three parts to it. One is molecular biology, which we have already covered extensively in 2 hours. If time permits, we'll do it again in the second part, but I've saved it for the last. अगर time मिलेगा तो, क्योंकि वो path के साथ integrated questions आते हैं. So that is one thing. The other part is the miscellaneous topics, where again you get a lot of questions from. So उसमें आता है enzymes, all of the glute stuff, vitamins. उसमें से बहुत क्वेश्चन आते हैं. पोरफायरिया, राइट. सो दोज आर द 4 टॉपिक्स जो हमारे मिसलेनियस है. ठीक है. एंड फाइनली वी हैव मेटाबॉलिज्म विच इज द एंटायर बायोकेमिस्ट्री, जो मतलब हमें problematic लगता है. So what we're gonna start off with the large chunk. It is much like surgery, if I can give you a correlation. जहाँ पे GI and Neuro is very big, but उसमें से उतने सवाल नहीं आते. So here also you have metabolism, जिसमें से आपको, there are no audio breaks. Metabolism जिसमें से उतने सवाल नहीं आते, but it's extensive, right? So we will basically understand the concept and you get like very conceptual questions from that. कोई भी नहीं पूछता आजकल that what is the rate limiting enzyme of this step. Although we will be doing it, but still like nobody is asking you such direct questions anyways, which we tend to focus on. They are asking you very very intricate questions, very very conceptual questions. All right. So वो concept को हमें समझना है in the metabolism aspect, and then bulk of the questions will be from inborn errors. All right, from metab. ठीक है. So I hope you got the gist of how to approach biochemistry. कि छोटे topics को master करना है, you have to understand and yes, answer clinical questions and USMLE kind of vignettes from the cycles, and then molecular biology will get you absolutely factual questions. Okay. Right. So with that note, let's begin. What we are starting off with in one slide, let's just do one short question, which is going to come from enzyme. So this will be like more of pharma, biochemistry, both. दोनों के ही questions आते हैं about competitive, non-competitive inhibition. You need not do first aid after this at all. Puri first aid has been covered. If you include molecular biology and if you include today's class, there is not a single thing which is not there matlab which is left in first aid. All right, so you don't have to do anything else in first aid, just do these two things, because I love first aid. मैं उसी से पढ़ती हूँ biochemistry, so that is what I have done for you. All right, so biochem and micro, which I tell you कि उसमें से पढ़ना है, मैंने उसी से पढ़ के पढ़ाया है. So you are sorted in that aspect. ठीक है. All right, so first I will see, I mean we'll focus on metabolism only, so whatever we can cover, ऐसा कोई plan नहीं है, जितना कर सकते हैं. चलो, so now come back and now let's focus on the enzymes. All right, so competitive non competitive inhibition. Thank you so much. Okay, so anytime there's an enzyme has a specific site where substrate binds. Okay, in competitive inhibitor, you have somebody who is a lookalike. बिल्कुल उसकी के जैसा लगता है, and it will bind to the substrate site, and that way the substrate will be knocked out. So it binds to the same site. So do you agree if the substrate increases in concentration, it can come and replace this dhokebaz? Yes, it can replace this dhokebaz competitive inhibitor. Yes, so here this is reversible if the substrate concentration increases. On the other hand, uncompetitive inhibitor binds to an allosteric site. दूसरी साइड पे बाइंड करता है. सो व्हेन इट बाइंड्स टू एन एलोस्टेरिक साइट, इट व्हाट इट डज इज वो इस साइट को चेंज कर देता है. इट मॉडिफाइज द ओवरऑल साइट. सो नाउ कैन दिस सबस्ट्रेट बाइंड टू इट. Now हमारा substrate cannot bind to it. All right, so this is not reversible. So this is the concept of non-competitive and uncompetitive. दोनों में ही same चीज हो रही है. In fact, in what I described was non-competitive inhibitor, where it binds to the allosteric site and it modifies the configuration. What happens in uncompetitive is it binds to the enzyme substrate complex. उसी से bind कर लेता है, so nothing will happen, you know. I mean, you are utilizing the substrate also, but the enzyme reaction is also not taking place. All right, so that is competitive, non-competitive, and uncompetitive. Now, only for exam purpose, only one thing you want to remember. In competitive, क से शुरू हो रहा है competitive. What is Km? First of all, what is Km? Km is the Michel's constant, which basically is the 50% Vmax पे कितना substrate. So it is the substrate at which the velocity is half of the maximum. All right. So you just want to remember कि Km क्या है. Yeah, Khyati is also Km. So apart from Khyati, the Km is that when you have half of Vmax, that is the substrate concentration. So Km is substrate concentration. So एक ही चीज याद रखो, that K and K stick together. In competitive inhibitor, will K be affected? Yes, K will be affected. So here Km reduces. Is there an audio issue? No, Payal, it's just you, I think. Okay, so Km reduces. So what happens to Vmax? Vmax remains absolutely normal. So the only thing I have to remember from this point onwards is K stick together. Competitive inhibition, Km reduces. ठीक है? And non-competitive inhibition में क्या होगा फिर? Non-competitive का non-competitive inhibition. So opposite. Here the Vmax reduces, but Km does not undergo any change. Km remains normal. Why Km remains normal? Because the substrate binding is not affected, right? Basically, the substrate is not able to bind only. Increasing the substrate concentration is not gonna help us. Okay, so that is what you want to remember. Yes, sorry, Km increases because basically that is what happens, right? The substrate concentration required for Vmax increases. Sorry, so Km is affected. Km increases. Anytime Km is affected, it will increase only, right? So Km increases and Vmax reduces. And in uncompetitive, where it's binding to the enzyme substrate complex only, here our same old rule, which was vowel stick together, is what you have to remember. वरना non और un mix हो जाएंगे. So यहाँ पे क्या है? Vowel stick together. So all reduces. Uncompetitive, all reduces. So here you will remember, matlab all reduce, matlab all affected. You know, you get my point. So Km increases and Vmax reduces. Okay, so both, all are affected. Not all reduce, but all are basically affected. All right, so that is what you want to remember. So these are the three things, and इसमें बस यही questions पूछते हैं, but they directly don't ask you this. They ask you in the form of two graphs. So that is what you have to realize. So here I am giving you this curve of a normal enzyme reaction. You have to tell me what? Yeah. Sorry. Here both of them are reducing. Here both of them are affected. Both of them are reducing. Okay. Sorry. Both of them are reducing. Okay. So what we have to remember is in this graph, what is competitive, what is non-competitive. For this, forget about uncompetitive. इसमें बस ये याद रखो कौन सा competitive है, कौन सा non-competitive है. So in the red one, what are we seeing? That it ultimately reaches the Vmax, right? So the Vmax is not affected. So when Vmax is not affected, there's only one thing which is affected? It is the Kmax. You can see how it has reduced, it has lowered, right? You can see how the Kmax has increased. So here, when we look at the Km, when it is affected, so this would be K se hi competitive. When Km is affected and Vmax is not affected, it is competitive. On the other hand, what is this? Wherein it is not reaching the Vmax, but Km is not altered. Km is the same. So what is this? This is non-competitive. So in this red and blue graph, the only thing you want to see is whether it is reaching the Vmax or not. That is what you want to see. The other thing is line weaver work. Again, very, very easy. Just yehi do concept pe. When, so here what we have done is instead of plotting the velocity and the substrate, I have done 1 by v, logarithmic kar diya hai. So I have done 1 by v and 1 by s. So what do I again see? That both of these curves, they are crossing at the y-axis. When they're crossing at the y-axis means Vmax is the same. So this is just like this where Vmax is the same, but Km is different. So Km is different, Km is affected. So this is what? Very nice. This is competitive. तो बस यही देखना है कि Vmax same है, Km is affected. So when K is affected, it is competitive. यहाँ पे देखो क्या हो रहा है. Look at the third one first. Third one में क्या हो रहा है? X axis पे मिल रहे हैं. When they are meeting at X axis, what does that mean? That the Km is not altered, but the Vmax is altered. When the Vmax is different, that means this is non-competitive. एंड थर्ड में क्या है, दोनों ही एक्सिस में इट इज अफेक्टिंग, राइट, दोनों ही अफेक्ट हो रहे हैं, दोनों ही डिक्रीज हो रहे हैं. सो दिस इज uncompetitive. So these are the questions that you get where they'll either give you this graph or they'll give you this graph. So just remember K stick together, all are decreased and isme Vmax is reduced. Okay, so this is about enzyme kinetics. The next thing that we want to do is the enzyme classification. Enzyme examples में बस एक जो baby school से ही पढ़ते हैं. For competitive inhibition, you can just remember one example which is malonate inhibits. Yeah, malonate inhibits which enzyme? Yes, succinate dehydrogenase, right? So दो उसका competitive inhibitor है, दोनों look alike होते हैं. So malonate inhibits succinate dehydrogenase and alanine inhibits pyruvate kinase. Alanine inhibits pyruvate kinase is an example of non-competitive. बस इतना दो example याद रख लो, बाकी इतना basic baby question तो नहीं पूछते. Then they will ask you here. Then they ask you the Othlill classification of enzyme classification. So here we have 6 classes and they literally give you example of enzymes and they'll ask you what is this type. 1, 2, 3, 4, 5, 6. ऐसे पता होना चाहिए. So these are the ECs. EC1, EC2, EC3, EC4, EC5, EC6. ऐसे बोलते हैं. So this is by the name only, the mnemonic is Othlill only. Don't make anything else. Othlill ही याद रखना है. Okay. So what is Othlill? Othlill, again, just understand it. It will be easier, है ना? तो oxidoreduction. Again, this is all based on concepts only. Basically, bringing all the pathways together is what should be the aim in biochemistry. Okay. So this is about oxidoreductive reaction. So जो भी oxidoreductase enzymes है, the main example here is going to be dehydrogenase. Tell me, dehydrogenase, when you remove, or basically when you are doing a dehydrogenase reaction, is this an oxidative reaction or reductive reaction? Yeah, so when you are removing hydrogen, you are making oxidation, right? So when you are removing hydrogen or you are removing electrons, that is oxidation. When you're adding electrons, that is reduction. So this is an oxidation reaction which happens. So this is all of your dehydrogenase. As far as the dehydrogenases are concerned, the H plus that I'm removing from the substrate, I need to give it to somebody. So who are the acceptors of this dehydrogenase is what we will integrate. Now just pay complete attention because now everything is gonna be interlinked. अब जो भी पढ़ेंगे सब कुछ एक साथ लाना eventually. Okay, so what are all the acceptors? One, you can have NADP, yeah, you can have NADH, and you can have FADH or FAD and NAD. Tell me, out of this, which does not produce any ATP for us? NADP or NADPH, let's just keep it all together, does not produce any ATP. ये कोई ATP नहीं produce करता. Then why am I giving my precious H, which I could have used for producing ATP, to NADPH? Because NADPH is very useful for me for a lot of stuff. What all can it do for me? One most important role in RBCs is glutathione reduction. It is very useful in antioxidant mechanisms, free radical scavenging, because it does glutathione reductase. Apart from that, this is also very useful for fatty acid and cholesterol synthesis, right? So fatty acid cholesterol synthesis के लिए मुझे चाहिए. And finally, as Harsh is correctly saying, I need it for the burst mechanism. Yes, chronic granulomatous disease में जो affect हो जाता है, NADPH oxidase. So these are the three roles for which I am actually investing in NADPH. All right, so this is something which is very useful, important. And where is NADPH produced? This is produced in HMP shunt. HMP shunt is quite underrated because it gives me two very, very important things. Okay, it gives me one 5 ribose sugars. It gives me pentose sugars. इसलिए इसको pentose pathway भी बोलते हैं. So HMP, remember two things it gives me very valuable. One is NADPH and the second one is ribose. Okay, xylose, ribose. Okay, so ribose is more valuable basically is what I want. Okay, so this is about NADPH. NADH, FADH, they are gonna produce ATP once they go into the electron transport chain. One molecule of NADH is gonna give me 2.5 ATP and one molecule of FADH is gonna give me 1.5 ATP. That is all you want to remember. Sath sath vitamins also very, very important. So whenever I use NAD, what is the cofactor vitamin which I need? NAD is B3 and FAD is B2. ठीक है, सो पहले लेटर में कौन आता है? EF, F पहले आता है, सो नंबर भी पहला देना पड़ेगा B2. NAD comes later, so B3. Do not mix this. Okay, so दो vitamin cofactors already done. All right, remember these. Everything will come together eventually. Okay, so this is about dehydrogenase, the very first oxidoreductase जिससे हमने काफी कुछ पढ़ लिया. Okay, so this is about O. T is transferase. Transferase is anything getting transferred. Most commonly what transfers is the phosphate group. Okay, so when I transfer an inorganic phosphate, that is called phosphorylase. And when I transfer an organic phosphate, which is basically my ATP, ADP, GTP, GMP, that is a role of a kinase. Very, very important. All right, so kinase bhi jab produce hota hai, it can be produced by two methods. All right, so this could be organic phosphate, so this could be oxidative phosphorylation or this could be substrate level phosphorylation. All right, so mostly in the body we have oxidative phosphorylation, which happens means I am adding one phosphate group and I am doing oxidation simultaneously. Most of the reactions are like that, except three reactions which directly give me ATP. हाथ में ATP देंगे, ना कि indirectly with NADH. They are called the substrate level phosphorylation reaction. There are three reactions. We will look at these three reactions and you will tell me later on. I will ask you कि बताओ कौन से तीन है. So two we will see in glycolysis and one I will see in Krebs cycle. I am already giving you a hint कि दो substrate level ना glycolysis में मिलेगा और एक substrate level Krebs. What is substrate level phosphorylation? Directly in hand they are giving me ATP. ऐसा नहीं कि NADH, FADH जैसा ले रहे हैं. Got it? So this is what you need to remember. अभी के लिए तीन important याद रख लो. Okay, so this is what you need to know about phosphorylase and kinase. No need for ETC, directly ATP देंगे. Right, that is what is substrate level phosphorylation. Got it? So kinases can act by two manner, oxidative phosphorylation and substrate level phosphorylation. Okay, so this is about transferases. Then we have hydrolases. Hydrolases are the simplest. They break a bond. So protease कर सकते हैं, phosphatase कर सकते हैं. Okay, they break bonds. Nothing to do much about hydrolases. Lyases, very, very important. So lyases क्या कर रहे हैं? Lyases are doing decarboxylation and synthases are also lyases. Remember, so synthase भी lyase है और decarboxylase भी lyase है. Let's first talk about decarboxylation. What is the cofactor for decarboxylation? Again, very, very important. Wherever we talk about decarboxylases, which is the vitamin that I am going to talk about? Yes, not biotin, but B6. Remember, it's going to be B6. All right. So B6 is what we talk about, decarboxylase. And carboxylase की जब बात करेंगे तो क्या बात करेंगे? Then we talk about biotin. Okay. So how do you not confuse it? B and C stick together. Does that help? B7 and carboxylase, right? So biotin and carboxylase. So B7 is carboxylase and B6 is decarboxylase. ठीक है, तो ये याद रख लो कि biotin है, B का B नहीं लेना, biotin का B लेना है. ठीक है, so biotin, which is B7, is what is carboxylase. Okay, I thought that you already knew this. Okay, so this is what we want to know about the cofactors. Decarboxylase, remember, most important decarboxylase में क्या याद रखना है? हाँ, अभी बताऊंगी, वो vitamins में जाके बताऊंगी. So that is vitamin K, but that we'll talk about separately. So here you want to remember in decarboxylase that there are various decarboxylases that we will see when we go to B6, but most important is what converts glutamate to GABA, histamine to histidine, है ना, तो वो सारा ही काम होता है decarboxylase का. Then coming to synthase. Synthase again very important. So what are all of the, so जिसके भी नाम में synthase आता है, everybody is a synthase except 4 enzymes whose name has synthases, but they are basically not type 4 EC. All right, they are not actually lyases. So these are the 4 synthases which are not EC4, which are not lyases. Got it? So these are the exceptions. So ye kon hai? NO synthase. Can you tell me first of all which amino acid comes in NO? Again, very important. Arginine, very nice. And what is this a type of? So this is an EC type 1. Okay, so NO synthase is EC type 1. It is actually a oxidoreductase. फिर बाकी के दो, glycogen synthase, citrate synthase, they are EC type 2, means they are transferases. And ATP synthase is EC type 3, which is hydrolase. Okay, so they are 4 syntheses which are not 4. Yeah, are you getting it? So now understand the symmetry. How do you remember it? Synthase actually क्या होना चाहिए? 4. There are 4 syntheses which are not 4. How many syntheses? 1. 1 is 1, first वाला. 2 are 2, दूसरे दो. Glycogen, citrate. And तीसरा बच गया, third is third. Okay, so this is how we remember 1, 2, 3, 4. Okay, so till 4 we have done our complete symmetry. All right, so this is about, yeah, this is 1, 2, 3, and 4. Now going on to type 5, again absolutely useless, it just changes the shape. All right, so this is isomerase or mutase, no nothing, just rearrangement of bonds. All right, so this is EC type 1, this is EC type 2, which is transferase, this is EC type 3, this is EC type 4, and this is EC type 5, and this is EC type 6. So finally we have ligases. Ligases are synthetase. So again, one mistake, this is synthase, this is synthetase. So do not make this mistake, this is synthase, this is synthetase, is a ligase, it adds it. All right, so this is what it's doing. So synthase is actually breaking, whereas synthetase is actually forming the bonds. And finally we have carboxylase, which we have done is biotin. So in addition to biotin, carboxylase needs 4 things. Remember, this is something which is very important. Carboxylase को 4 चीजें चाहिए. One is definitely biotin. Obviously it needs carbon dioxide क्योंकि carboxylase कर रहा है. It also needs ATP and it needs magnesium. So these are the 4 things that it needs. You got a similar question on pyruvate dehydrogenase के components, right? So similarly, this is one question that you can anticipate कि carboxylase को क्या 4 चीजें चाहिए. So biotin, CO2, ATP, and magnesium. These are 4 things that it needs, and all of the ligases will use ATP. Okay, apart from that, just remember this general rule. Magnesium, not just carboxylases, but your phosphorylases and your kinases, transferases and ligases use magnesium. The only exception here is pyruvate kinase. Where will you study pyruvate kinase, guys? Which reaction? तो सबसे बेसिक सबसे पहले पढ़ेंगे glycolysis, right? So glycolysis, link reaction, no. सबको biochemistry बहुत ही खराब है. Pyruvate dehydrogenase is link reaction, right? So remember, glycolysis का last step is pyruvate kinase. All right, so that also uses magnesium. It's a kinase, it also uses magnesium, but it uses potassium more. So if you have both options, mark potassium. Okay, so ये बस इतना सा याद रख लो. Fine. So this is the Auth-Lil classification wherein you will get factual questions from. I hope this is clear so far. Now going on to again one short question that you get from here is about glucose transporters. All right. So we have SGLT and we have GLUT. Tell me, SGLT is what kind of transport from physiology? If I ask you, is it active transport, secondary active transport, primary active transport, facilitated diffusion? ऐसे मिस्टेक नहीं करनी ना. दिस नॉट फैसिलिटेटेड. सोडियम ग्लूकोज दो तो है ही. सो दिस इज सेकेंडरी. इट इज डिपेंडेंट ऑन सोडियम, राइट? सो इट इज डिपेंडेंट ऑन सोडियम. सो फॉर ग्लूकोज टू एंटर इट इज गोना नीड सोडियम. तो ग्लूकोज एंड सोडियम कैन ओनली गो टुगेदर. 2 फ्रेंड्स साथ में होंगे तभी क्लास में एंटर कर पाएंगे, अकेले नहीं जा पाओगे. सो दिस इज सेकेंडरी एक्टिव ट्रांसपोर्टर. सो दिस इज ओनली unidirectional or is it bidirectional? This is only unidirectional. All right, so this is only unidirectional, and the cost of SGLT is the fact that now you're going to have to throw the sodium out, and for this you are going to need a sodium potassium ATPase pump. So this requires energy, right? So this requires energy. So secondary active transport SGLT I don't give to everybody, I only give it to special people. So I have SGLT1 and I have SGLT2. LT1 किसके पास है? एक ही जने के पास. So 1 means intestine. 2 is with 2 people. So 2 is with intestine and 2 is with kidney, right? So this is what you need to remember. In nephro, I told you one extra point that SGLT1 is there in the proximal straight segment, if you remember. So that is just very extra point, but even if you forget about it, it's okay. So just remember this basic fact that typically 1 is in intestine, 2 is in intestine as well as kidney, and then you know about SGLT2 inhibitors, which are your uh, flozins, right? So this is about SGLT. So what are glutes? Multiple times asked question. Glutes are your facilitated diffusion, right? So here you have these receptors, glutes, which are in the membrane and they are allowing bi-directional flow of glucose. तो फिर तो glucose should come in cell, it should go back also. तो cell को glucose कैसे मिलेगा? So that is why a cell has definite mechanism in place where the moment glucose comes in, it will make it phosphorylated. So the moment phosphorus is added, now it is trapped. So this is called as the phosphate trap that the cell has. All right, so it will trap the glucose inside so that it cannot go out. So we need to remember that this is bidirectional actually. Okay, so this is about facilitated glucose that you want to remember. All right, facilitated transfusion. Now you will get questions from the various glutes and where they are located. So the one which we always need, the critical organs will have GLUT 1. 1 means absolutely essential. Okay, so that is what you want to remember. No, 2 is intestine and kidney. Okay, yeah. All right, so that is what you want to remember. In PST, you can have SGLT1 actually. Okay, so that is what you want to remember. All right, so now go on to this GLUT K locations. Very, very important. Lots of questions. So this is what we want. These are the crucial organs. So what are the crucial organs? One thing which is exclusively dependent on glucose is RBCs in fed, fasting, and starvation. Remember, everything it needs ग्लूकोज सो आरबीसी को तो हमें ये देना ही पड़ेगा व्हाट एल्स brain is very much dependent on glucose then if we have placenta very much dependent on glucose and finally kidney also so four things which have GLUT1 rbc brain placenta and kidney the crucial organs which have high affinity so even basal fasting state mein also we are giving them glucose similar is GLUT3 except for rbc everything else is the same so that is how we'll remember GLUT1 and GLUT3 together that इनका very high affinity है but brain placenta and kidney only and not RBCs come here okay then let's go to the fed state now these are the areas which are very important so fed में हमारे पास lots of glucose है so I want to make glycogen from that glucose so I need to give this to liver I want my insulin to be released so I want to give this to pancreas because only then pancreas will sense it and it will release insulin whereas who will absorb glucose fed है तो absorb करने के लिए intestine need to have GLUT2 and finally the last thing is the kidneys again so PCT of kidney because we want to excrete also we want to sense and we want to reabsorb and all okay so this is about the fed state very very important GLUT4 is the only one which is insulin stimulated so now when insulin tells the body yeah this is the insulin depend so all of these are insulin independent this is the one which is insulin stimulated okay so now when insulin tells that all right we have a lot of glucose give it to the organs which need it so muscle and fat right so all kinds of muscle skeletal muscle cardiac muscle and adipose tissue so it is going to give the signal to all of these that now you can take the glucose and you can basically create whatever you want all right so muscle and adipose tissue it is giving insulin okay so this is what you want to remember yeah GLUT2 has yes lesser affinity of course lesser affinity because it is only effective in very high state fed state muscle cardiac muscle also okay cardiac skeletal smooth all muscles okay so that is what you want to remember fine and finally when we go into fructose 5 is 4 is fructose so this is what you want to remember and this is obviously in the small intestine and sperms okay so this is what you want to remember 4 is 5 6 and 7 bhi hota hai but not very very important okay so this is about all of the GLUT transporters and their location, which is again one independent question that you need to remember. Now, very, very important, we are going into the fuels which are needed by the various tissues in all of the fed, fasting and starvation state. Okay, so that is about this. So सबसे पहले सबसे easy, RBC is the one which does not need anything. It is very loyal that I will only need glucose irrespective of body status. I need glucose, so this I can fill straight away. Then which is the only one which does not utilize glucose even in the fed state, which does not even utilize. All right, so what is the difference? So when we have eaten within 2 hours, that state is called fed state. After eating up to 12 hours, that is called as the fasting state. And 1 to 3 days you have not ate, you are called starving. Okay, so what we say 2 घंटे में जब हम बोलते हैं ना I am starving, that is not correct biochemically. All right, so starving is when you have not eaten food for 1 to 3 days. Okay, right, so that is the difference. So now which is the only one, as you guys were correctly saying, which does not utilize glucose even in the fed state? So that is heart. So heart wants fatty acids from the first only. ठीक है, so fatty acid यहाँ पे आ गया. बाकी सबको ही क्या चाहिए? In the fed state everybody is pretty happy, give us glucose and we are sorted. Okay, so सबसे पहला समझ में आ गया. How we are gonna approach it is RBC needs glucose all the time and heart needs fatty acid even in the fed state. Now going on to the fasting state. Now I have glucose sources which are getting depleted. All right, but there is again one thing. So now when the glucose stores get depleted, we are going to call into account fatty acids. Yes, so सबको ही fatty acid चाहिए होता है, but there is one exception here. There's one exception here where we cannot have the fatty acids cross the blood-brain barrier. So again, brain will have to utilize glucose here, right? Brain will have to utilize glucose because fatty acids cannot cross the blood-brain barrier. So everybody else utilizes fatty acids except for brain. तो ऐसे करके याद रखेंगे. Finally, going into the starvation phase. In the starvation phase, what is the point of ketone bodies? So ketone synthesis and ketone, not synthesis, but ketone breakdown only happens in 3 areas. What are those 3 areas where you have ketone breakdown? So remember, ketone breakdown hoga, then you will be like beam. So beam is the mnemonic that you remember. Yes, you become mota, so you remember beam for ketone bodies. So कौन से जगह है जहाँ पे ketone bodies का breakdown होगा and we can utilize ketone bodies in the starvation? B for brain, where I can utilize ketone body, heart and muscle. So these are the 3 areas where I can utilize ketone bodies. लिवर में क्या यूटिलाइज होगा? कैन लिवर फॉर्म कीटोन बॉडीज? लिवर डज फॉर्म कीटोन बॉडीज बट लिवर कैन नॉट ब्रेक डाउन कीटोन बॉडीज. सो लिवर इज द generous being who synthesizes ketone bodies but it doesn't utilize, it makes it for beam, right? So इसको क्या utilize करना पड़ेगा? It will have to utilize proteins, it will have to utilize amino acids. And muscle हमारा and fat, what about the fat? Fat has fatty acids, so fat will utilize fatty acids, right? So fat is still utilizing fatty acids, liver is utilizing amino acids. And here you want to remember, in the muscle can utilize anything that they have, right? तो मसल का कोई ईमान धर्म नहीं है. They have everything at their disposal, they can use whatever they want. Fine, so this is again a very important table, so again do not cram it. क्या करना है? RBC सबसे simple. After that go in this order where heart will utilize fatty acids, then remember beam utilizes ketone body, बाकी everywhere else fill it with fatty acid. Fill FA except here where you have amino acids. Okay, so this is the approach to this table कि पहले ये भरो, जो स्क्वायर्स है वो भरो, बाकी everything else is going to be FA. Okay, so this is about the fuels. Now going on to what everything boils down to. This is the basic concept जो अपने को समझ में आना चाहिए, which is the fed and fasting stage and the regulator. If you just do this, then you will never have to memorize any table of any regulator. All of the regulators will sort themselves out. Okay, so just very logical. Whenever you have had a lot of food, बहुत खाना खाया है, तो बॉडी में क्या रिलीज होगा? इंसुलिन. Which glut will tell that tell pancreas that glucose has come into the body? 4? No. Which glut will tell pancreas? Pancreas में कौन सा glut है? Glut 2. Okay, so GLUT2 will tell pancreas that it's time to secrete insulin. All right, glucose has come. So insulin gets secreted. Now insulin will have GLUT4 and then it will promote all of the others. Oh, wait. Okay, so this is about so this is about the fed state where insulin acts into the picture. All right. So in the fed state, what is going to happen? What are the pathways that insulin is going to promote? So the pathways that insulin is going to promote are predominantly the anabolic pathway, because we have a lot of fuel. So we want to utilize this fuel, we want to store it. Right. So predominantly anabolic pathways. So anabolic pathways like what all? What do you think should get synthesized? Should I synthesize glycogen? हाँ, glycogen synthesis कर लेते हैं. Should I store fatty acids? Yes. Should I store cholesterol? Yes, cholesterol भी बना लेते हैं. So let's make fatty acid. Let's make cholesterol. Let's make triglycerides. Right. So all of these things are getting synthesized. Can I do protein synthesis as well? Protein synthesis as well. But before I go on to all of the anabolic pathway, do you think first I should generate some energy? Person has eaten food because they want energy. So सबसे पहले ये सब storage करने से पहले immediate काम तो कर ले. So immediate काम is going to be by what? Yeah, by glycolysis. Do I also need the link pathway? Yes, only then it will go to Krebs cycle, isn't it? So I need glycolysis, I need link pathway, only then it will be diverted into the Krebs cycle. Okay, so this is what insulin is promoting. Now, how does body know? How does insulin do it via secondary messengers? So remember, insulin reduces the CMP. The moment CMP is low, protein kinase is low. And when protein kinase is low, dephosphorylation happens. So in sub-K, rate regulating steps are going to be activated when they are dephosphorylated. Very, very important. So remember, insulin I is inhibition. Remember, inhibition, inhibit phosphate, cut down phosphate, dephosphorylation. All of these pathways will be active in their dephosphorylated state. Is this clear? So that is the common concept that you want to remember. So even though glycolysis, yes, is a catabolic pathway, but that is what I need immediately, right? So that is what you need to remember, that insulin promotes anabolic except glycolysis, but still it's very logical कि पहले खाना खाए तो energy तो दो. So that's going to be glycolysis and link pathway. Got it? So this is about the insulin thing. Then when we talk about fasting, whenever we are in a fasting state, now my main hormone is going to be glucagon. Can I say the same thing is going to be in diabetes mellitus also? Diabetes mellitus, what happens? Insulin is not there. Yeah, so same thing. Diabetes mellitus pathway also the same thing, wherein you have diabetes or you have fasting state. So here now I need the energy. So all of the catabolic pathways will now come into play. And exact opposite mechanism. CMP increases, protein kinase A increases, and now you have phosphorylation, which will activate all of the enzymes. So, kya teen pathway? What are all the catabolic pathway that you know? One, I can break down my glycogen. Yeah, I can break down glycogen. So this is going to be glycogenolysis. Then I can do fatty acid oxidation here. I can do lipolysis in the form of fatty acid or fatty acid oxidation. Then I can do gluconeogenesis. Gluconeogenesis sounds like an anabolic pathway, isn't it? But it's not an anabolic pathway. It's actually a catabolic pathway, right? So gluconeogenesis, we are making glucose from other sources. So again, that's a catabolic pathway. And finally, ketone body, both ketone body synthesis and utilization. Because why both? Because two different organs are doing it. Liver is synthesizing it for beam to utilize, isn't it? So both of them will come here. So these are the points you need to remember, that ketone body synthesis is not anabolic. No, it is what the liver is doing for utilization. Okay, so gluconeogenesis, ketone body synthesis are both catabolic pathway, even though on by name they sound anabolic. So that is what you want to remember. Okay, what PRK, protein kinase A will phosphorylate all of these enzymes. So all of these enzymes are going to be active in their phosphorylated state. I hope this is clear to all of you. Now, where do they occur? So here again, you have to remember a cross wala mnemonic. I don't know if you guys remember, but there are these cross mnemonics where you have to what I have told them in this offline class, but right now what you want to remember is that insulin is going to be activated where? Is it going to be in the mitochondria or is it going to be in the cytoplasm? So catabolic pathway, remember C for catabolic. So catabolic pathway cannot be in cytoplasm. So C and C will not stick together. That is what is the meaning of opposite wale mnemonics. In the end, we will consolidate all of these mnemonics also. But right now, you have to remember C and C won't stick together. It's opposite. So catabolic pathway, all of these will occur in mitochondria, whereas all of the anabolic pathway will occur in cytoplasm, right? So this is about our location also that you want to remember, that ये सारे cytoplasm में है, ये सारे mitochondria में है. Exception is what here? Exception is three pathways which occur in both. They occur in both, so you need to hug. Two people will hug, right? So you need two to hug. So that is what you need, cytoplasm and mitochondria to hug. So what is H? Yes, H is heme synthesis, porphyria wala pathway. We'll see both. U is urea cycle. Very nice. We'll need both. And G is what? G is gluconeogenesis, right? So gluconeogenesis also needs both, wherein pyruvate will come from the mitochondria and then it will occur in the cytoplasm. Okay, so these are the pathways which occur in both of the sites. Fine. So this is what you want to remember here as far as the pathways are concerned. Purine pyrimidine ko bhi bhul jao. That is not important. That's a separate pathway only where DNA is taking place. Okay, that is not concerned with insulin glucagon. Uska fasting state pe koi lena dena nahi. Okay, so this is what you want to remember as far as the gist goes. Now, are you ready to bring all of this together? Before that, glycogenolysis is this, no? Glycogenolysis, catabolic pathway, no? Okay, so this is what, yeah, good. That is one exception wherein glycogenolysis is not mitochondrial, but it is cytoplasmic. All right, so yes, that is indeed one exception wherein it is cytoplasmic and it is not mitochondrial. Okay. Cool. And even the link reaction for that matter, even the link reaction actually takes place on the inner mitochondrial membrane. Okay, but not very, I mean, this is important. All right, so inner mitochondrial membrane. Okay, so ye hum, anyways, I'll tell you in detail, but grossly you can remember this. Fine. So what is the gist? Fed state, insulin, dephosphorylated, anabolic glycolysis, link pathways activated. Fasting stage or diabetes, we have phosphorylation and the catabolic pathways will be activated. Catabolic pathway take place in mitochondria, anabolic pathway take place in cytoplasm, hug takes place in both. Okay, so this is what you want to remember. Now going on to blood glucose sources. Aerobic, mostly aerobic is preferred. Wherever we don't have the pathway for aerobic, we'll go for anaerobic, but that is not determined by insulin per se. Okay, so now going on to the sources of blood glucose. Whenever we have food ka glucose, right? So whenever we are in a fed state, that is what it will be, the fed, like the food glucose will be utilized. But when you are in a fasting or a starvation phase, what are all of the things which can give us glucose? So the next preferred source, very nice, is going to be the liver glycogen. Now next up will be glycogen ko basically bula. Thank you, because I have started from the basics first ना, तो पहले मैं basic समझूंगी फिर आपको पढ़ाऊंगी. That's right. Okay, so this is liver glycogen that you need to remember. कि first up will be glycogen. तुम आओ, हमारे पास glucose नहीं है, so glycogen from the liver will be released. If glycogen stores are also depleted, now time will come that अब बुलाओ fats को और protein को, isn't it? So now we bring out fatty acids and we bring out the amino acids, right? So do you think fatty acids and amino acids can give rise to glucose? For sure. So fatty acids ke liye, what is that one fatty acid which I need? The buzzword that you want to remember. Yeah, so they can create gluconeogenesis, right? So these are going to be substrates for gluconeogenesis. Very nice. So the buzzword you want to remember is three wale, odd chain fatty acids, three chain fatty acids, odd chain fatty acids is what you want to remember. So propionyl CoA, never acetyl, never even, because even ka end product hota hai acetyl CoA, but odd chain ka product hota hai propionyl, and it's only propionyl CoA which can actually take part in gluconeogenesis. Yes. What about amino acids? All of the glucogenic amino acids. What is the most glucogenic amino acid? Most glucogenic is alanine. Apart from that, all glucogenic amino acids, which are your 18 amino acids, there are only two purely ketogenic amino acids. What are the only two purely ketogenic amino acids? Dono start with L. So you have leucine and you have lysine, right? So leucine and lysine are the only two purely ketogenic amino acids. Baki sare can again contribute into gluconeogenesis. Okay, so this is how basically we stay alive even in starvation stage. First up, glycogen will help, and then we will have everybody else who comes into play for gluconeogenesis. Ketogenic means they do not take part into gluconeogenesis. They will form ketone bodies. They will give body the energy via the ketone bodies. All right. वो gluconeogenesis नहीं कराएंगे. They will form ketones. Okay. And then there are both ketogenic and glucogenic. You don't want to remember all of that. Okay. एक सवाल आया था INICT में that out of carbohydrate, fat and yeah, liver will undergo glycogenolysis. Liver is responsible mainly for glycogen synthesis also and lysis also. Tell me, hi, I think VR has not read biochemistry ever. So मेरे से भी बुरा. You are like me, but it's okay. We'll get through together. Okay, hopefully you are understanding now. Highest thermic effect इसका है. It is for protein. Yes, so protein has the highest thermic effect. This came in INICT. कि out of protein, carbs and fat, highest thermic effect इसका है. एक और ऐसा ही one liner question आया था about respiratory quotient. That carbohydrates का respiratory quotient कितना होता है. So this we used to study in physics. No, what is the definition of respiratory quotient? It is the amount of CO2 which is released by oxygen. है ना, तो बस खाली ये याद रख लो that carbs का RQ is 1. है ना, तो ये सब पूछते हैं. ठीक है. अब this is what first aid does, which nobody else can do. Like this is the beauty of first aid, है ना, कि जो बाकी कोई नहीं कर सकता, first aid ही कर सकता है. Okay, so this is what you now need to remember. So before we go, don't relax, all is well, all is well. So this is what biochemistry is all about. बस इतना सा समझ लो, and after that it's just about rate limiting enzyme, ये है ये वो है. तो इसके बाद सारे facts ही हैं, बस understanding खत्म हो जाएगा. Half of the stuff you've already understood, half of the stuff you have to now understand. So just be with me, very light, है ना, आराम से chill. Okay, so what, anytime, let's just imagine हमने खाना खाया, right? We have just had a lot of cake. Okay, cake is good. Yeah, so we had a lot of cake. So the moment I have a lot of glucose in my body, where all will the glucose go? So the first glucose that I want to send is I want some energy, right? I'm feeling very down. मैंने juice पी लिया, मैंने cake खा लिया, so now I have a lot of glucose. So this glucose will go into glycolysis, right? So the first chain that you are seeing is glycolysis. So glucose eventually, just remember. So this is biochemistry for dummies who do not know anything about biochemistry. You will understand it today. All right. So glucose gets converted into pyruvate. So this is what happens in glycolysis, that glucose gets converted into pyruvate. Now pyruvate has a lot of options in life. There are two things which have a lot of options in life, कि मुझे ना life में कुछ भी बनना है. They are these two people. जो arts लेते हैं, they have a lot of options ना, कि वो कुछ भी बन सकते हैं. They can become architect, they can become designer, whatever. So pyruvate and acetyl CoA are the art students, है ना. वो life में कुछ भी बनना चाहते हैं, वो बन सकते हैं. So what all can pyruvate become? If pyruvate goes via link reaction, means if insulin is active, do you remember this was by insulin? So if insulin is active and we are in a fed state, so what will happen? Pyruvate will be pushed to acetyl CoA. This is the main link reaction. Okay, now focus here, no comments, just focus. Okay, वरना point भूल जाओगे, फिर पूछोगे ma'am what? Fine. So pyruvate to acetyl CoA is pyruvate dehydrogenase link reaction. So this acetyl CoA, once it's formed, again it has a lot of options, but let's say it goes into its main pathway, which is the Krebs cycle and TCA cycle. Krebs cycle, TCA cycle gives us a lot. It gives us a lot of energy. It gives us a lot of intermediates as well. So this is a lot. This is a lot of there's a lot of good things for us. Okay, so this is what you need to know. Do you realize I did not include TCA cycle in anabolic also, in catabolic also? Why not? Because it is amphibolic. Remember, it is both. It is catabolic also and it is anabolic also. Okay, because it breaks down also, but it gives us a lot of intermediates also. So that is why you want to remember that it's amphibolic. So nobody will ever ask you this. Okay, so this is what is TCA cycle. Yeah, it occurs in mitochondria. From this step, PDH onwards, it occurs in mitochondria. Okay, so remember, glycolysis हुआ, pyruvate बना, acetyl CoA बना, went into the TCA pathway. Now, what else can happen to pyruvate? If aerobic pathway is not there, right? If I do not have the aerobic pathway, it will undergo anaerobic breakdown. So, anaerobic breakdown of pyruvate is called lactate via lactate dehydrogenase. That is why when when you are in a state of anaerobic, है ना, basically muscles को energy नहीं मिल रहा, they will produce lactic acidosis. This is the mechanism of lactic acidosis in the muscles which happens, right? So this is pyruvate to lactate via lactate dehydrogenase, and this reaction basically utilizes one NADH, right? So this is what happens, NADH to NAD conversion हो जाता है, right? So one NADH here is actually utilized. Okay, so this is what you want to remember कि यहाँ पे एक NADH आता है. So this is lactate dehydrogenase. On the other hand, can pyruvate become alanine? Yes, extremely important. So two crucial transamination reactions are very, very important, very underrated, but very important. So transamination, what two things? So one is pyruvate. Pyruvate can get converted into alanine. And what is the other transamination reaction that you want to know? What is the other transamination reaction? Oxaloacetate gets converted into aspartate. It is not just one way. These are both reversible reactions. So what is this enzyme here? SGOT or SGPT? Obviously pyruvate hai, so this is SGPT. SGPT. ASTLT, ALT, SGOT and AST. Right, so these are the two names. So aspartate transferase or SGOT, ALT and PT. कैसे confuse नहीं करना? So once you remember these names, you can remember this reaction also, right? Because AST is aspartate and O is oxaloacetate. ALT is alanine and P is pyruvate. So you just want to remember that in OT you make a toast, है ना? तो याद रखो कि ओटी में भूख लगी है, so you make a toast in OT. So AST in OT is what you want to remember. If you remember toast in OT, you will remember all four of this. This is like that. Sensitivity wala kal jo kara tha, it's like that. Once you remember this, you will remember everything here, right? So you just remember toast in OT. So AST is aspartate and oxaloacetate, and this is this. Fine. So this is about these two. So what all can pyruvate become in life? Pyruvate in life can become acetyl-CoA, go into Krebs cycle, can become lactate in anaerobic condition, can become alanine. So this is about pyruvate. Now let's go to acetyl-CoA. Now let's go to acetyl-CoA. Yeah, about alcohol, yes, it is AST, again toast in alcoholic, right? So you toast, make a toast in alcoholics, so that is how you can remember. AST increases in alcoholics. Everywhere else in viral hepatitis it is ALT more than AST. Okay, तो वो भी toast से आप याद रख सकते हो. So from here today onwards two toasts, OT में toast बनाएंगे और alcoholics toast करेंगे, two different toasts. Okay, right. Now acetyl CoA क्या क्या कर सकता है? Acetyl CoA can make TCA. Then acetyl CoA, when we are in a fed state, do you remember in a fed state I want to go into anabolic pathway? जितना भी glucose था, so much glucose came, I did energy, I had every energy. But now my body says that you need to make some storage for future purposes. So now acetyl CoA is like, okay, let me become fatty acid triglycerides, right? So acetyl CoA gets converted into malonyl CoA, which forms fatty acid. So this is fatty acid synthesis. It can become triglyceride. So fatty acids with glycerol becomes triglyceride. Okay, so this is about fatty acid synthesis. It can also become cholesterol. So cholesterol बनने के लिए it will first become acetoacetyl CoA and HMG CoA. Now HMG CoA has two options in life. In a fed state, it becomes cholesterol, but in a fasting state, HMG CoA becomes what? It becomes ketone bodies. Very, very important. So in a fed state, it becomes HMG CoA reductase. Do you remember this enzyme? It gets inhibited by a drug. What is that drug? HMG CoA reductase. Statins, right? So we know statins are inhibiting cholesterol synthesis. So they are inhibiting this pathway. So in a fed state, HMG CoA becomes this. But in a fasting state, HMG CoA gets converted into ketone bodies. So I hope itna pathway is clear. Now let's go into the various gifts TCA cycle is giving us. TCA cycle is giving us a lot of gifts. What are those gifts? So now let's assume we are in a fasting state. We are in a fasting state, and now I want to utilize my TCA cycle to the maximum. We'll go to hours. Batao, just hold on. Whatever I am not saying, I'm not saying for a reason. Just trust me. Okay. Now we go on to TCA cycle. TCA cycle में जा रहे हैं. What are all the intermediates? So now we have gone into a fasting state. है ना, fasting state है, हमें energy बनानी है. So what are all the intermediates? So First, we want to break down protein. So how does protein, we talked about gluconeogenesis. Yeah, so we want to do gluconeogenesis. For gluconeogenesis, I can utilize protein and I can utilize lipids also. How do I utilize proteins? You guys already know it. Odd chain fatty acids and all of my glucogenic amino acids will give me propionyl CoA, and this propionyl CoA will get converted into methyl malonyl CoA, which will get converted into succinyl CoA. So can I say that this is PMS? So here there's a very, very important order that you want to remember. This is PMS. Propionyl CoA, methyl malonyl CoA. Methyl malonyl CoA, succinyl CoA. Methyl malonyl to succinyl. This is something that we have already read in vitamin B12 deficiency. Do you remember methyl malonic acid accumulates? This is one enzyme I used to distinguish folate and B12. Folate में ये नहीं accumulate होगा, only B12, because it is only B12 which is responsible, right? So methyl malonyl CoA. And P2M, what is P2M? P2M is a carboxylase. So for carboxylase, here I need biotin. Yeah. So here I need biotin. So there are two enzymes, two cofactors which I need in PMS. Remember biotin and remember B12. So B7 and B12. So for this, you want to remember that menstruation usually starts by 13. Yes. So there are two ages which are premenstrual. This is not PMSing. This is premenstrual. So premenstrual is 7 and 12, right? So biotin and B12. Okay, so remember PMS, premenstrual, B7 and B12. Will you remember this? So this is very, very important. How propionyl CoA comes into gluconeogenesis. It comes via succinyl CoA. Via succinyl CoA, it will bring energy via TCA cycle. Okay, so ये हो गया succinyl CoA. Then how does lipid come into picture? So lipid, triglycerides I told you are made up of what? Triglycerides are fatty acids. They are, to be precise, 3 fatty acids plus 1 glycerol. Yeah. So what it does is it breaks down to form glycerol, and glycerol gets converted into DHAP. Glycerol 3-phosphate banke, it is a polymer of DH. It is an isomer, not a polymer, isomer of DHAP. DHAP is a pathway of glycolysis and gluconeogenesis. Okay, so this enters the pathway via DHAP. Got it? So ये बस ये याद रखो, lipids are coming via glycerol, and amino acids and fatty acids are coming via propionyl CoA. So this is about how these two substrates are entering into gluconeogenesis. What is gluconeogenesis? It is nothing but the reversal of glycolysis. All of the enzymes are reversible except 3. We'll talk about this in detail, but only 3 enzymes I need to reverse, and this is the same as gluconeogenesis. So 2 pathways we've already done: glycolysis, gluconeogenesis. Got it? Then one more hero. One more hero here is oxaloacetate, which has a lot of potential in life. So oxaloacetate is the direct thing which can enter gluconeogenesis from the TCA. It can directly jump into gluconeogenesis, or it can directly jump into urea cycle also. Oh my god, urea cycle. So oxaloacetate and aspartate. I already know this, guys. I already know this toast in OT. I already know that this is AST or this is SG. Yeah. So now look at oxaloacetate. It can go into TCA cycle. It is the main hero of TCA cycle. If it doesn't want to, it can go into gluconeogenesis. If it wants, it can directly jump into urea cycle. So these are the various links of all of the pathways. In addition, you have one HMP shunt. What is HMP shunt? So now we have had a lot of glucose. हमने glycolysis भी कर लिया, हमने stores भी बना लिए. Still I have glucose left. So I'm like, let me create that glutathione reductase के लिए NADPH. So NADPH बनाना है, 5 ribose sugars बनाने हैं. So I utilize HMP. So for any glucose, 90% pathway is this. 10% pathway from glucose goes into HMP. Okay, so this is what you want to know. Baki, if you've had milk, तो galactose. If you have had fruit juice, तो fructose. उसका ज़्यादा कोई role नहीं है. And we already know fasting and fed state, we have glycogenolysis and glycogenesis, which is happening parallelly in the liver, in the cytoplasm. Got it, everybody? So this is how the various pathways are linked. So very quickly, I'm telling you the links. What are all the heroes? First hero, pyruvate. Pyruvate in life can become what all? It can become lactate. It can become alanine, and it can become acetyl CoA. right? It can become acetyl CoA, lactate dehydrogenase, alanine via transferase. Acetyl CoA can become a lot in life. Acetyl CoA can undergo TCA, it can undergo cholesterol, it can undergo ketone body, and it can undergo fatty acid synthesis. ठीक है. ऑक्सैलोएसिटेट इज आवर थर्ड हीरो. क्या क्या बन सकता है? यूरिया साइकिल में जा सकता है, टीसीए में जा सकता है, ग्लूकोनियोजेनेसिस जा सकता है. ग्लूकोनियोजेनेसिस टू थिंग्स कैन आल्सो गो, प्रोपियोनिल कोए एंड ग्लिसरॉल. Everybody, did you get this? So this is how all of the pathways are together. Yes, all of the R's are rate limiting, but we will not do this right now. We will study each pathway in detail. फटाफट फटाफट से करेंगे and फिर वापस से रिवाइज करेंगे. Remind me, ma'am, we need to go back to this pathway and we need to see rate limiting of everything. Okay, so this is what is about all of the pathways. So I hope you got how body is doing stuff, है ना. Body is so wonderful, उसने सबके pathway बना रखे कि fed में ये करना है, fasting में ये करना है, intricately उसके खुद के metabolisms ही regulate कर रहे हैं, right? So this is about all of these pathways. Now we are going into individual stuff. Okay, now we are going into individual stuff. Thank you. Thank you. Chalo. So up the baby stuff. Now if I teach you glycolysis, you will be like, ma'am, glycolysis, really? You are telling us what are the three kinases which are irreversible? But I will tell you. Okay, so now we go into the various steps of glycolysis. So now when we go into steps of glycolysis and baby stuff that you've studied in the first year, like how many ATP are produced here, you will only tell me the answers. Okay, so what happens in glycolysis, and we'll study gluconeogenesis simultaneously. So all of the enzymes are reversible here except three. The rough idea is कि सारे ही kinases. चलो अभी ध्यान दो वापस. Thank you for the love. वापस आ जाओ अब. ठीक है. Now in 1 hour we want to complete all of the metabolic cycles. Okay, तो cycles हो जाएंगे. फिर we have all the baby stuff which is remaining. Okay. चलो, so तीन kinases हैं which are irreversible, बाकी सारा ही reversible है. So right now am I studying one cycle or am I studying two cycles? एक chapter पढ़ रहे हैं, दो chapter पढ़ रहे हैं. Glycolysis पढ़ रहे हैं, gluconeogenesis पढ़ रहे हैं, right? So glycolysis has three irreversible steps which I need to replace in gluconeogenesis. बाकी सब same है. All right. So what happens? Glucose gets converted to glucose 6 phosphate via hexokinase or glucokinase. Two enzymes. What is the difference? Let's see that right here. So we have hexo and we have gluco. Gluco, L for liver. This is present in L for liver and pancreas. I only want liver and pancreas to get the glucose when it's very high. Again, go back to this pathway. Khana khaya, cake khaya, right? Do I want most of the glucose to go into the body and form energy, or I want the glucose to go for glycogenesis or HMP? I don't want glucose to go into these two pathways because these are the competitors of glycolysis. पहले मुझे energy चाहिए. So my hexokinase is what is there in every other tissue. It is there in every tissue and this has a higher affinity. So it has a lower Km. Do we already know this Km and Vmax? हाँ, इसका ना lower Km or lower Vmax है. Means it has a higher affinity. All right. So hexokinase has a higher affinity and that is why preferentially it will go into all of the other tissues for glycolysis. So everywhere hexokinase is taking place. But in liver, after every tissue has gotten its glycolysis done, then liver and beta cells will get. Why? Because inka Km is very high. When Km is very high, that means that the affinity is lower. Got it? Everybody, affinity is lower here. So this is induced by insulin. After that, insulin will come into play once everybody has gotten their own glucose for glycolysis. Got it? So glucokinase, you just want to remember, is preferentially in the liver and pancreas, insulin induced hai. Inhibitors are very important. So for right now, just remember everywhere, unless mentioned otherwise, the product of the reaction is gonna inhibit, right? Allosteric inhibition. जो product है, वही enzyme को inhibit करेगा. So because hexokinase is the norm. So right now, one statement you want to remember that hexokinase is the norm, glucokinase is an exception. Yeah. So wherever is the norm, the product is gonna inhibit the enzyme. Same happens here. But in glucokinase, it is fructose 6-phosphate. It's the next product which inhibits. Okay, so these are two important pointers that you want to keep in mind right now. Okay, no, it is glucokinase in this case because we want hexokinase. We want all of the tissue to first get their own glucose even before insulin comes into picture. Okay, because insulin ka main pathway is anabolic reaction. Even though it is promoting glycolysis ki wo hoye, it is allowing glycolysis. Insulin ka main pathway is anabolic reaction. So we don't want insulin to be activated just yet. वरना वो ग्लाइकोजेनल सिंथेसिस करा देगा, वो फैटी एसिड सिंथेसिस कराएगा, तो इंसुलिन को थोड़ा दूर रखना है. पहले बाकी टिश्यू को दे तो दो, so that it can create its energy. Got it? So this is about that. One more factual question जो अपने को याद रखना है, glucokinase deficiency is a cause of MODY, maturity onset diabetes of the young and gestational diabetes. तो बस ये इतना एक म्यूटेशन होता है ना बॉडी में, that is what you want to remember. Okay. All right, so this is what we want to remember. No, insulin dependent was the muscles, right, which were utilizing muscles and the muscles. So what was insulin dependence? It was the muscles and the adipose tissue, correct? So the cardiac muscles and adipose tissue which were insulin dependent, not the liver. Liver ko to hum pehle hi de rahe. Okay, right. So this is about hexokinase, glucokinase. So this is the first kinase which is irreversible. Uske baad we have phosphofructokinase. This is the rate limiting here. So jahan pe do arrow hai, yellow highlighter means it is yellow highlighter means it is irreversible. Okay, so hexokinase first irreversible, phosphofructokinase second irreversible, but it has a blue line also. Blue line means it is no problem. It is rate limiting also. It is rate limiting also. And then third irreversible is pyruvate kinase. All right, so third क्योंकि इसमें yellow highlighter भी है. Got it, everybody? So these are the three irreversible steps. So now let's see what is happening. Glucose वो बताऊंगी बाद में, just hold on to that thought. When we go to insulin regulation I will tell you that. Okay, so we have glucose 6 phosphate, uske baad that converts into fructose 6 phosphate, fructose 1,6 biphosphate, because this is phosphofructokinase. So tell me one thing, hexokinase, glucose to glucose 6 phosphate, 1 ATP is utilized. Yes, 1 ATP is utilized. Fructose 6 to fructose 1,6 phosphate, is 1 ATP utilized? Yes, we are adding 1 phosphate bond. All right, so यहाँ तक हमने 2 ATP use कर ली हैं. So this is the expenditure that has happened so far. After that, we have aldolase, which breaks this into 2 DHAP or 2 glyceraldehyde 3 phosphate. Fructose 1,6 biphosphate is broken into 2 of these compounds. All right, now comes the special enzyme. The special enzyme is G3P dehydrogenase. All right, so what G3P dehydrogenase does is it does an oxidative phosphorylation. So this inserts an inorganic phosphate. When I insert an inorganic phosphate, when I'm making glyceraldehyde 3 phosphate into 1,3 biphosphoglycerate, technically तो मुझे ATP चाहिए होता. No, this is not substrate level phosphorylation. Technically तो मुझे ATP चाहिए होता. I am adding one phosphate, right? I am not creating phosphate. I am adding a phosphate. I would have needed ATP, but this is a very special enzyme which will just insert free of cost inorganic phosphate. All right. So this is just insert an inorganic phosphate, and this is a very chalak enzyme. Why chalak enzyme? Because एक तो free में phosphate डाल भी दिया, and it is a dehydrogenase. So it also produces an oxidation reaction. It also produces one NADH for me. तो एक तो खर्चा भी बचाया एंड गिफ्ट भी दिया, एनर्जी भी बताया. सो इनऑर्गेनिक फॉस्फेट डाल दिया एंड NADH बना दिया. टेल मी हाउ मेनी NADH नाउ एवरीथिंग हियर ऑनवर्ड्स इज गोना बी मल्टीप्लाइड बाय 2, राइट? मल्टीप्लाइड बाय 2 हो जाएगा. सो 2 NADH. देन वी हैव 1,3 biphosphoglycerate to 3 phosphoglycerate. So this is a kinase. Yeah, so when it is a kinase, whatever I said was not very important, like kharcha bachaya, I mean nothing important there. Okay, so 1,3 biphosphoglycerate to 3 phosphoglycerate, this is a kinase. So now tell me, is this substrate level phosphorylation? Yes, this is a substrate level phosphorylation where you directly get ATP. How many ATP? ATP into 2. Yes, we get ATP into 2. And the third one, pyruvate kinase. So after that, we have PP, which gets converted to pyruvate. So this is pyruvate kinase, which again produces ATP into 2. So these are the 2 substrate level phosphorylation reaction which are directly producing ATP. I told you there are 3 things, 2 which are there in glycolysis. So these are the 2, phosphoglycerate kinase, pyruvate kinase. So just look at this figure and look at the color index. The yellow highlighter are the 3 ones which are irreversible. Got it? 3 enzymes that I want to remember. The blue one is the rate limiting phosphofructokinase. And then we have the ones in orange which are our energy producing ones. So ये बहुत चालाक enzyme, very intelligent enzyme, which is utilizing an inorganic phosphate, producing 2 NADH, and then we have substrate level 2 ATP. I hope you guys got this. So glycolysis, you don't need to write the complete pathway, just remember all of these. Going on to the inhibitors. So iodoacetate and arsenite are the two ones which inhibit glyceraldehyde 3-phosphate. This was the chalak enzyme, the smart enzyme. We are blocking it by these two. The beauty of arsenite is it allows glycolysis to continue. Glycolysis will continue, but it will not be able to produce ATP. It will not produce ATP. It is arsenate, I am sorry. All right, so this is no ATP, but it will allow glycolysis to continue. Iodoacetate, on the other hand, will inhibit this reaction. All right, it will inhibit this reaction completely. Sodium fluoride inhibits enolase. Can you tell me where this is useful? Very nice. This is in gray vacutainer. Yeah, so this is in gray vacutainer basically that I use sodium fluoride. So there they ask you what is the anticoagulant which is used in gray vacutainer for glucose estimation. So there you will not say sodium fluoride. There you will say what? There you will say it is, yes, it is potassium oxalate. It is not sodium fluoride. Sodium fluoride is only there to inhibit enolase. Okay, so I hope all of the associated questions you guys got. Now let's talk about the energetics. So when we are talking about the glycolysis, how many ATPs did I use? It is this. Arsenate is this enzyme only. Okay, right. When we talk about the energetics, how many? Yeah, just forget about arsenic for the moment. Just it is one of the inhibitors here. Okay, so 2 ATPs we have used here. So we have used 2 ATPs. How many ATPs did I get from substrate level phosphorylation directly? 4 ATPs, right? On the other hand, कौन सा NADH मिला है? We have gotten 2 NADH, right? So I have gotten 2 NADH, which means 2 into 2.5, which means 5 ATP. So if I have an aerobic pathway wherein NADH is eventually allowed to go into electron transport chain, how many will I have? 5 plus 4, 9 minus 2. So 7 ATPs I have earned from glycolysis in an aerobic state. On the other hand, if NADH is not allowed to go into electron transport chain, what is the net gain? 2 ATP. So from this point onwards, remember one number. In anaerobic glycolysis, how many ATPs are gained? 2 ATP, right? So when I am using this number, is this other number important? 7? 7 is not very important because we are still not accounting for what happens to pyruvate, right? Pyruvate will eventually go into Krebs cycle and it will produce a lot more ATPs. So I don't care about 7. But 2 is very important because here everything stops at this point, right? So that is what you want to remember right now. Yes, 32 मिलेंगे उसमें eventually. जहाँ पे 7 we will count as this and then we will add more stuff. Okay, but for anaerobic, the ball stops here where it is 2. And में दो extra word है from aerobic, anaerobic, so 2 ATPs in anaerobic. Okay, I hope this is clear. So when we talk about RBCs, RBC में क्या हो रहा है? So RBC has both of these pathways which are going on, right? So RBC has 90% glycolysis, wherein what kind of this does RBC have? Mitochondria? RBC doesn't have any mitochondria, isn't it? So it cannot produce this. It will only produce 2 ATPs. And it also has another pathway which is called as the RL shunt. What is RL shunt? RL shunt is a useless pathway. It is a useless pathway wherein there are no ATPs which are produced. Yes, there are no ATPs which are produced. Then why is it doing this? You guys are telling me the full form. Wonderful. For congratulations for that useless knowledge that you have. Why are you remembering the full form? Forget about it. So RL shunt, where you have no ATP, what is the utility? The utility is it converts this. Do you see this compound? 1,3-biphosphoglycerate. 1,3-biphosphoglycerate is converted into 2,3-biphosphoglycerate. Do we know this from our respiratory physio that 2,3-BPG is very, very useful because 2,3-BPG reduces the affinity of hemoglobin and it allows more release. Yeah, it causes a rightward shift. Wonderful. So this is why it is doing, it is investing in this useless pathway with a useless name to create this useful product, which is 2,3-BPG. Got it? So this is what happens in RBC. So these are all of the questions about glycolysis and other things. Thank you. जो आपको पता होना चाहिए. Okay, so this is about glycolysis. तो दूसरा pathway भी हम कर लें. Do I know one more pathway now? I know one more pathway. So इसी को उल्टा कर देते हैं. That is gluconeogenesis. So what are the only three things I need to worry about? Only three things I need to worry about are pyruvate kinase, phosphofructokinase, and hexokinase. What was the rate limiting enzyme? No, I'm not zooming because it is not needed. Just hold on. इसी में देखो. So here we have pyruvate kinase, we have phosphofructokinase, hexokinase. If I zoom, you will be like, ma'am, upar karo, niche karo. Because you can see here, no, whatever is needed. Just trust me. You don't need zoom here. Okay. So these are the three levels where you have to reverse. Okay. So what do we need? Pyruvate kinase. All right, pyruvate kinase ki jagah. Now I need two things. Why two things? Because now the thing is, when I'm doing gluconeogenesis, this pyruvate has already gone into the mitochondrial membrane, right? So this pyruvate loves inner mitochondrial membrane because that is where pyruvate dehydrogenase lives. So pyruvate bante hi goes into mitochondria. So did I tell you in hug we need two people? To hug we need two people. So was hug including gluconeogenesis? Yes. So now first change from glycolysis, this is completely cytoplasm, whereas this is occurring in both mitochondria and cytoplasm. Got it? Okay, so that is the first thing. The second thing, so now the pyruvate which has gone into the mitochondria will need first enzyme which is pyruvate carboxylase. So pyruvate carboxylase se bana oxaloacetate, our wonder compound. So this is oxaloacetate which then gets PEP carboxykinase and gets converted into PEP. So this pathway, pyruvate kinase, gets replaced by two pathways, pyruvate carboxylase and PEP carboxykinase. Do I need to tell you guys the activators, or you guys are pros in that? Do I need to tell you that pyruvate kinase is activated by insulin, whereas pyruvate carboxylase is activated by what? Obviously gluconeogenesis is going to be created. Gluconeogenesis is going to come into play only when I am in a starving state, right? So that is when we have glucagon into play, right? So this you already know, I'm not going to repeat this, right? So pyruvate carboxylase and pp carboxykinase, now it has come in. So oxaloacetate comes into cytoplasm. All right, so why we are doing this double pathway is because I want to bring pyruvate to cytoplasm via oxaloacetate. So oxaloacetate can cross the mitochondrial membrane and will come into cytoplasm. Okay? Then same enzymes are doing the job till here, till fructose, till PFK1. So because this is PFK1 where fructose 6 phosphate gets converted to 1,6 biphosphate, when I want to convert 1,6 to 1, I use a biphosphatase. Very easy, right? Yeah, everything, like everything here is glucagon only. Also glucagon nahi, only glucagon. दूसरा तो इंसुलिन है ना. So remember, fructose 1,6 biphosphatase is what is happening here. And इसीलिए zoom नहीं कर रही थी क्योंकि फिर नीचे का रह जाता है. So this is fructose 1,6 biphosphatase. And finally, the last pathway which was hexokinase is glucose 6 phosphatase. So now answer two questions for me as far as this goes. Not two questions, but I will tell you two things. One is that this takes place in endoplasmic reticulum. एक तो थोड़ा minor point. Smooth endoplasmic, whatever. Does this happen in muscle? Can muscles participate in gluconeogenesis? Muscles cannot participate in gluconeogenesis because muscles have this enzyme which is absent. बेचारे muscle के पास glucose 6 phosphatase है ही नहीं. All right, that is why muscles will do what? If muscles want energy, they will convert this glucose 6 phosphate into glucose 1 phosphate, right? They will convert it into glucose 1 phosphate and then utilize it. So remember, muscles cannot participate in gluconeogenesis because they do not have glucose 6 phosphatase. Got it? What was the rate limiting enzyme, guys? Rate limiting enzyme phosphofructokinase. Fine. So let's go back to our mega chart. And if phosphofructokinase is rate limiting enzyme here, what will be the rate limiting enzyme in gluconeogenesis? Same, it will be PFK phosphatase, right? It will be the biphosphatase that you have. So ये दोनों हमारे हो गए RR. All right, so ये समझ में आ गया, दो rate limiting enzymes done, दो pathways done. Got it? So और क्या लिखा हुआ है उस slide में? Primary in liver doesn't happen in muscle because it lacks glucose 6 phosphatase. I already know that. What are the substrate for gluconeogenesis? This ma'am has told me in great detail that it can be pyruvate because pyruvate is definitely there. It can be lactate because lactate can convert into pyruvate. Glycerol, how will glycerol enter, guys? यहाँ से सीधा glycerol will directly convert into glycerol 3 phosphate, which gets converted into dihydroacetone phosphate, and it will continue upwards. Propionic acid, how propionic acid was entering the pathway, guys? Propionic acid was getting converted into PM and S, right? So methyl malonyl and succinyl. Succinyl CoA se TCA is a cycle. From succinyl, it will convert into oxaloacetate, and oxaloacetate will continue the pathway. Got it? All amino acids, same thing. And any TCA intermediate. Can I say any TCA intermediate can become oxaloacetate? Yes, this is my hero. So any TCA intermediate can actually give rise to gluconeogenesis. So, which is the only art student which is missing here? The one which is the most important, जो सब कर सकता है but gluconeogenesis नहीं कर सकता, acetyl CoA. So remember the most important thing, acetyl CoA is an activator of gluconeogenesis, but it cannot take part because acetyl CoA does not have 3 carbons, it has 2 carbons, right? So acetyl CoA does not participate in gluconeogenesis, not a substrate for gluconeogenesis. Most important question. Okay, so far so good. Are you guys understanding? ठीक है, तो 2 pathways हो गए. अब rate limiting पे जाते हैं. This is again baby stuff, you already know it. So tell me, in the fasting state, just tell me that it activates gluconeogenesis. Okay, so in fasting state, increased glucagon, just put a tick in your mind if you know this. Fasting में increased glucagon है. Does it increase CMP? Yes. Does it increase protein kinase है? Yes. So whenever protein kinase A is activated, we will have gluconeogenesis which is activated. So for gluconeogenesis, which pathway should be activated? Which enzyme should be activated? It should be phosphatase. Yes, so it should be fructose 2,6 biphosphatase. So this is what happens when you have glucagon, when you have fasting. On the other hand, when you have insulin fed state, what will happen? Low CMP, low protein kinase A. So what will be activated? Glycolysis. So that is why for PFK, phosphofructokinase 1 will be activated here. All right. So right now, I just want you to remember that there are 2 things. PFK1 and PFK2 are the twins which act together. This is just complication for no reason. You could have just said that PFK1 is activated. It would have been simpler enough. But no, it acts via its Judva brother. Judva brother means twin brother. So PFK2 bhi active ho jayega. Alright, so PFK2 gets activated and that activates its brother, which is PFK1. Okay, so that's just an intermediate which is there for no reason. Okay, because they were twins, they act in conjunction. So this is a potential MCQ where you don't want to confuse. You just remember PFK2, PFK1 are both promoters of which pathway? Glycolysis or gluconeogenesis. They are both activators of glycolysis. Simple. है ना? तो is this complicated table? Complicated at all? Nothing. इसमें क्या है? दोनों rate limiting enzyme है. I already know कि fed state में glycolysis will be promoted. Fasting state में gluconeogenesis. So this enzyme will be activated. Here this enzyme will be activated. Okay. ठीक है? नहीं समझ में आया? तो भूल जाओ, इसमें कुछ है ही नहीं. Just forget this slide. Now focus here. When I was talking about this, where I have glycolysis which is happening like this, insulin promote करे, भूल जाओ सब कुछ. Now just listen to me. When we talk about glycolysis, insulin will activate it or glucagon will activate it? Insulin. So insulin should activate which enzyme? Phosphofructokinase 1 or fructose 1,6 biphosphatase? PFK1, because PFK1 is the rate limiting enzyme. PFK1 is the rate limiting enzyme of glycolysis. So now you just want to remember PFK1 is not directly activated by insulin. Insulin activates PFK2, which activates PFK1. Bas. So can I say insulin activates PFK2 and it also activates PFK1? Huh, okay. And what does glucagon activate? Glucagon activates gluconeogenesis. So glucagon will activate fructose 1,6 biphosphatase. बस इतना सा तो था. समझ में आ गया? तो इन्होंने कॉम्प्लिकेट करके न्यूमोनिक बना के और कॉम्प्लिकेट ही करा है. सो डू नॉट इवन लुक एट दिस न्यूमोनिक. ओके, सो दैट इज व्हाट यू वांट टू रिमेंबर. हाँ हर्ष, that was just an explanation for glucokinase, hexokinase. All right, but overall insulin is activating glycolysis for sure, right? It is activating glycolysis. Okay, तो उसको इतना दिल पे नहीं लेना. दैट वाज अ कॉन्सेप्ट ओनली फॉर ग्लूकोकाइनेज एंड हेक्सोकाइनेज. ओके, बट एनीवेज ग्लाइकोलाइसिस विल बी फेवर्ड बाय इंसुलिन. ठीक है. ऑल राइट, सो दिस इज व्हाट इन्होंने बेसिकली, इनको लगा कि वी डू नॉट नो अबाउट सीएमपी एंड प्रोटीन काइनेज, दैट इज व्हाई दे हैव एक्सप्लेन्ड इट इन डिटेल. बट डिड वी ऑलरेडी नो इट? हमें तो पहले पता था. दैट्स व्हाई वी डोंट नीड दिस. ये उन लोगों के लिए जिनको ये सब पता ही नहीं है फॉस्फोराइलेशन का. बट वी ऑलरेडी नो दैट phosphorylation, dephosphorylation, where we know that insulin inhibits and insulin enzymes are activated in their dephosphorylated state. So this is for babies who do not know this concept. Okay. Anyways, so we've done this. Now we want to move further in life. We've done glycolysis, we've done gluconeogenesis. Now let's proceed below. Where are we going, guys? Where are we going? We are going down. We are going here. We are going into acetyl CoA and Krebs cycle. Let's make some energy. All right. So that is where we are going. We are going into mitochondria to make some energy. Okay. So mitochondrial membrane में जाएंगे तो क्या होगा? We will have our enzyme pyruvate dehydrogenase. Yeah, this is fun, no? So we made pyruvate. अब energy और बनाते बहुत मजा आ रहा है ना. तो और एनर्जी करने के लिए we have pyruvate dehydrogenase, which is the main link enzyme, right? So here this is all happening now in the mitochondria. Okay, Krebs cycle happening in mitochondria, link reaction happening in the inner mitochondrial membrane. Now this enzyme is very important. Do you guys remember my vitamin class? B1, what are the enzymes which are cofactors where B1 is a cofactor? B apt. Yeah. So what are all of these enzymes? Branch chain alpha keto dehydrogenase, A for alpha keto glutarate dehydrogenase, P for pyruvate dehydrogenase, and T for trans ketolase. Forget about trans ketolase for the moment. वो उसके assay में use होता है, RBC trans ketolase. We don't care about it. All three of these enzymes undergo what reaction? All three of these are oxidative decarboxylases. Yeah, oxidative decarboxylases. ये सारे enzymes हैं. So what do they do? Oxidative decarboxylases, they remove CO2, they do oxidation by removing H plus and giving it to NADH. So all of these are oxidative decarboxylases. All three are same enzyme, same function, same cofactors, same everything. Particularly alpha keto and pyruvate are my two main hero enzymes, which I love. So oxidative decarboxylation is the reaction which is happening. So what happens? Pyruvate to acetyl CoA. So क्या क्या करना है? Oxidative decarboxylation. So remove CO2, make NADH, and there is one CoA group which has suddenly come. So do I need to add a CoA? Obviously add करना पड़ेगा. So that is all that there is. So they ask you various subunits of the pyruvate dehydrogenase. So for this you will just remember a number series B1235 plus lipoic acid. So no mnemonic, nothing. Number 1, 2, 3, 5, lipoic acid. 4 we do not like. 4 को भूल जाओ. 1, 2, 3, 5, lipoic acid. So B1 क्या है? I already know. Thiamine is the main cofactor for this. B2 क्या है? What is 2? 2 is FAD. 3 is what? 3 is NAD. I know because it is in alphabetical order. 5 is what? Pantothenic acid. Anytime you have CoA, you have pantothenic acid. And lipoic acid is there, which is also coming. So these are the 5 cofactors. So they asked you an image-based question. They asked you the 5 components. Is this very easy? इसमें कुछ complicated है? This diagram looks so complicated, but ऐसा कुछ नहीं. इसके बस 3 part होते हैं. So if you want to go into the details, E1 is pyruvate dehydrogenase. फिर वो lipoic acid को आपको कुछ करना है. You have to acetyl transferase and you have to do dehydrogenase. Okay, so here you have TPP which is attached. Here you have lipoil which is attached. And here you have FAD and NAD which is again. All right. So they ask you what are all of the cofactors which are needed for pyruvate dehydrogenase. B1 is needed for the main enzyme, pyruvate dehydrogenase. Okay, so this is where I have thiamine which comes into play, B1. फिर acetyl transferase है. So acetyl transferase is your CoA transferase basically. Acetyl CoA. CoA is coming here. So when CoA comes into play, we have lipoic acid which comes into play. And anytime I want to do CoA, I also need B5. Okay. And finally, here I'm doing all of the oxidation. So FAD comes here and NAD comes here. Okay. Very good, very specific question that you have asked VR, but I don't know how to answer it. Okay, because you neither remember question nor you remember answer. You just remember that you don't remember. So I don't know how to help you remember. Okay, so this is pyruvate dehydrogenase. Fine. So this is about PDH. So have we done the process? We have converted pyruvate to acetyl CoA. Okay. Hopefully now you will remember stuff. Okay. TPP is nothing but thiamine. All right, thiamine is written as TPP. ठीक है. चलो, तो ये हो गया हमारा पीडीएच. तो फटाफट से जिसको समझ नहीं आया, जिसको समझ आई गया होपफुली सबको, तो नाउ लेट्स गो इनटू द फैक्ट दैट पायरुवेट इज अ हीरो. या पायरुवेट इज अ हीरो. सो पायरुवेट का मेन एंजाइम क्या था? पायरुवेट जो हम अभी तक पढ़ रहे हैं, पायरुवेट डीहाइड्रोजनेज, राइट? What do you think should inhibit pyruvate dehydrogenase? Should it be its product? Absolutely, it should be its product, right? So nothing else, that you want to remember. Acetyl CoA will inhibit the pyruvate dehydrogenase. So that is all that I want to know here. Nothing much. I already know this fate. What else can pyruvate become into? I already know this. Lactate dehydrogenase, by reversible. So NADH lactate बनाएगा. And can it become oxaloacetate? Where have I seen this? Have I seen this reaction? Yeah, I already know it. What are you talking about? I know everything about this. So this is where gluconeogenesis. So gluconeogenesis, it will utilize an ATP, pyruvate carboxylase, and PP carboxykinase. Two enzymes lagenge, but eventually it will become oxaloacetate and PP, right? And finally, you have this. You have ALT, which is alanine, right? So this also I know, ALT and SGPT. I know everything about the transaminases. Okay, did you guys get this? So, और क्या बता रहे हैं ये लोग? So, if you have PDH complex deficiency, do you need to know this, or can you solve this by concept? That if this reaction is not happening, what will happen? Preferentially, these two will happen. So, you will have alanine and lactate which are forming, all right? So, that is where the pyruvate will get shuttled and you will have lactic acidosis, you will have increased serum alanine. Yes. So, basically take more ketogenic diet instead of more glucogenic diet. So in keto diet, one of you was asking na, keto diet में क्या होता है? Your main energy source is ketone bodies. Your main energy source is not glucose. आप carbs नहीं खा रहे. You're eating only proteins and fats. Okay. So this is what you want to know. Fine. सारे ही transferases, the two transferases that we saw, what was the vitamin cofactor? B6. Pyruvate carboxylase. Do I already know all carboxylases? Means biotin, means B7. Dehydrogenase 1235 lipoic acid. Do you guys know this? 1235L. I know it. Lactic acid dehydrogenase, LDH, B3. B3. This we didn't know. This is B3. B3 is what? NAD, because this is already there. This also I know only. Right? So this is NAD. Where does this happen? This happens wherever you don't have mitochondria. So predominantly RBC, kidney medulla, lens, testis, cornea, WBC. That is where you have the anaerobic glycolysis. Can you tell me how many ATPs will be produced here? Wonderful. 2 ATPs. चलो फिर आगे बढ़े. So let's say that we have made this reaction by pyruvate dehydrogenase. Okay. Oxaloacetate वाला नहीं समझा तो you will go back, Pulkit, and you will listen to gluconeogenesis again, because this is gluconeogenesis वाला pathway only है ना. Pyruvate carboxylase, gluconeogenesis, oxaloacetate. ठीक है. चलो, तो फिर हम जाते हैं क्रेब साइकिल. नीचे जाता है क्रेब साइकिल. सो कैसे बना क्रेब साइकिल? वी हैव ऑलरेडी मेड एसिटाइल कोए. सो फार जस्ट टेल मी, इतना एनर्जेटिक्स खत्म कर लेते हैं. सो फार हाउ मच ग्लूकोज हैव आई, हाउ मच एनर्जी हैव आई प्रोड्यूस्ड फ्रॉम ग्लाइकोलाइसिस? कैन यू जस्ट रिकॉल एंड टेल मी? It was -2 ATP plus 4 ATP from substrate level and plus 5 ATP from NADPH, right? So it was basically what? It was 7, right? It was 7 which had come from glycolysis, provided it is aerobic. Link reaction से कितना बना था? 1 NADH, but how many NADH did we produce? 2. It was now 2 pyruvates which I had, right? So 5. ठीक है, तो यहाँ तक I know the math that this is 7 and this is 5, right? So it is 7 plus 5. Now let's see what Krebs can do for us. Okay, are you guys with me so far? ठीक है, तो यहाँ तक हमारा maths sorted है. Now let's go to Krebs cycle. चलो, तो अब और energy बनाते हैं. So how do I create energy here? First of all, tell me, is the first substrate of Krebs cycle acetyl CoA or oxaloacetate? कैसा सवाल है ये, दोनों ही तो मिलके बना रहे हैं. बट इफ आस्क्ड, it is oxaloacetate. The main hero of Krebs cycle is not acetyl CoA. The main hero is oxaloacetate. Why so? Because one of you mentioned one term which is called as anaplerotic reaction. What is anaplerotic reaction? सबसे पहले तो आंसर कर दो, एम्स का सवाल है. Should I give a poll? Wonderful. Most of you are answering it. So when the product is producing the substrate itself, right? Abhi bataungi, abhi to explain hi nahi kara. So basically, when it's a cycle, it is not a. So understand the difference between a cycle and a pathway. A pathway is what is unidirectional. A cycle is wherein every product is giving rise to the next thing itself, right? So when I can produce pyruvate to oxaloacetate, means basically my oxaloacetate can come from what is giving rise to acetyl CoA, है ना. So this pathway is never gonna stop, वो अपने आप ही basically अपने आप को promote कर रहा है. Did you get this? It is promoting. Pyruvate in itself is promoting the substrates. So this is called as an anaplerotic reaction. If you didn't remember, just remember this fact that pyruvate to oxaloacetate is called as an anaplerotic reaction by pyruvate carboxylase. This is an example of an anaplerotic reaction. So this is how pyruvate can give rise to the first substrate of the Krebs cycle. In fact, pyruvate gives rise to both the substrates of the Krebs cycle if we look at it, isn't it? So acetyl CoA plus oxaloacetate are combining to form citric acid. Can you tell me how many carbons in acetyl CoA? I guess I don't know how many people, because it doesn't show me how many people, but you so 2 carbons, and oxaloacetate is 4 carbons, right? So citric acid में कितने carbon हो गए? 6 carbons. Citric acid is 6 carbons. Aconitase is just forming citric to isocitric acid, so still 6 carbon. Now isocitrate dehydrogenase, the first dehydrogenase. Let's begin the energy process. So NAD to NADH, one NADH I got here. अभी मतलब 2 से बाद में multiply करें, right now just assume 1 NADH and you have CO2 getting released. So alpha ketoglutarate, how many carbons? 5 carbons. This is my main enzyme. Do I already know everything about this enzyme? Batao. Alpha ketoglutarate dehydrogenase is an example of what? It's an example of oxidative decarboxylation. Is it the same as pyruvate dehydrogenase? Absolutely same. Decarboxylation, CO2 nikla. Oxidation, NADH mila. What is the cofactor? B1 is the cofactor, right? So everything is the same here. So now how many carbons does succinyl CoA have? 4 carbons. बस इसके बाद कुछ सोचना नहीं. Everything else remains 4 carbon till oxaloacetate. Got it? Yeah, I asked substrate level, but still has substrate level come? अभी तक तो हम NADH ही खेल रहे हैं, right? So far I've gotten 2 NADH. Now comes succinyl CoA. Succinyl CoA to succinate is succinate thiokinase. So what is this? This is substrate level, right? So this could be ATP, this could be GTP, this could be both, but more commonly it is GTP. All right, so this could be both GTP or ATP. But do you agree that now this is my third example of substrate level? 2 kinases already done. Yeah, what were the 2 kinases in glycolysis? Can you tell me? One was pyruvate kinase and one of the other was? देख ही लेते हैं. So one kinase was this phosphoglycerate kinase and one was pyruvate kinase. So नीचे वाले दो were substrate level and G3P dehydrogenase चालाक enzyme was utilizing phosphate and producing NADH. ठीक है? So समझ में आ गया. 3 examples of substrate level we have done. Okay, so this is about the succinate. Succinate gets converted into fumarate. Fine. Can you tell me where fumarate is also gonna go into? Fumarate is again something which is needed for यूरिया साइकिल. वेरी नाइस. एंड यूरिया साइकिल का एक और इंटरमीडिएट भाई कौन है? oxaloacetate, right? So oxaloacetate is also interlinked with the urea cycle by means of aspartate, isn't it? So सब कुछ linked है. We only need to remember it. Okay, so this is fumarate. Fumarate gets converted into malate. Malate gets converted into oxaloacetate and in the process produces one NADH. Remember here, जहाँ पे fumarate का process है, FADH comes into play. So how many NADH have I produced? 1, 2 and 3. 3 NADH I have produced here, but totally it's all multiplied by 2. So can I say in Krebs cycle, what are the energetics which I have now? 6 NADH. How many FADH? 2 FADH. And how many substrate level? 2 ATPs or GTPs substrate level. तो जरा math करो कितना हुआ? 6 into 2.5. What is 2.5 into 6? How many ATPs are produced here? 15. 2 into 1.5. 1.5, 3, and this is directly 2. So 20, right? So this is 20. So total kitna bana? 32 ban gaya? Yes. So this is the complete maths, complete business जो मेरा हुआ via oxidative or aerobic glycolysis, right? So I have 32 versus अगर anaerobic है तो कितना हुआ? 2. Did you get it? So this is how you want to remember. So do you want to remember this complete math? Not really. So these are the only two numbers you want to remember, that it's 32 or it's 2. ठीक है, बस इतना सा याद रखना. Okay, so ये हो गया हमारा energetics. Now what have I written here? So right now I just want to integrate two things for you. Before that, just remember, do not confuse malate with malonyl CoA. Why not? Because malonyl CoA, remember, is not the same. ये दिखता similar है, but it is the complete opposite. This is the guy who inhibits everything. Where did we study malonyl CoA? Let's go back. World is a small place. Malonyl CoA was my PMS, right? Was there in the PMS, propionyl methyl malonyl CoA. So this is where methyl malonyl, or basically this is different. This methyl malonyl, this malonyl CoA is even different. But for now, just to integrate, remember, methyl malonyl CoA will come into succinyl CoA play. That is there. But for malonyl CoA, it sounds like malate, but it is an inhibitor of TCA. It is actually an inhibitor of TCA. Fine. So this inhibits TCA, and not just TCA. It inhibits a lot of other things. It also inhibits ETC ka second complex, which is succinate dehydrogenase. Very nice. It also inhibits beta oxidation of fat. Fatty acid breakdown bhi inhibit karega by inhibiting the CPT1 enzyme. Okay, so yes, this is different from methyl malonyl, because methyl malonyl बेचारा थोड़ी block कर रहा है. methyl malonyl तो खुद PMS बन के pathway को support कर रहा है. Where is VS? There's no VS anywhere. Okay, so this is about malonyl CoA. Fine. Yeah, malonate or malonyl CoA, same thing. Okay. Yeah, malonate also you can remember. Malonate or it's malonyl CoA. Okay, versus. Okay, where have I written versus? ठीक है. So that is what you need to remember. ओके ओके, wherever I can't see. चलो, तो ये हो गया. ठीक है, सबको समझ में आ गया ना? सो ये अच्छा अच्छा, ये ओ वर्सेस मैलोनिल कोए. ओ प्रिंटेड भी समझ नहीं आया तो हैंड राइटिंग कैसे समझ आएंगे? दिस वर्सेस मैलोनिल कोए. Okay, right. Now I want to tell you two things. I want to tell you two things which are the other things that alpha, why world is a small place. है ना? Did you realize world is a small place in biochemistry? World is a very small place, but world is a smaller place because I want to show you two similarities between alpha ketoglutarate and oxaloacetate. Both of them can again contribute to formation of amino acids. Did we see how amino acids are giving rise to Krebs cycle? हाँ, तो they will be like, आप भी मुझे कुछ दो बदले में. So बदले में what are we giving? So these two are like, okay fine, we will form few amino acids for you. Okay, so alpha ketoglutaric acid, basically if I add an amine group, so let's say this is alpha ketoglutarate. If I add one amine group, what does it form? It forms a glutamate. If I add one more amine group, it forms what? It forms glutamine. So did I get two acidic amino acids? Yeah, I got two acidic amino acids, glutamine and glutamate. On the other hand, oxaloacetate is also like, मैं भी कुछ help कर देता हूँ तुम्हारी. So oxaloacetate, if I add an amine group, what do I get? I get aspartate. If I add one more amine group, what do I get? I get aspargine. Yes, so do I get two more acidic amino acids? Yes, these are the only four acidic amino acids that you have. कहाँ से बने? Through this. So when we are giving this TCA, TCA is also giving rise to four amino acids. Got it? Everybody, so this is what we want to remember here. Isocitrate dehydrogenase doesn't use B1. No, doesn't use B1. दिखता वैसा ही है but it doesn't use for some reason. Okay, हाँ break मिलेगा 15 मिनट का. Fine. Did you guys understand the entire Krebs cycle? चलो अभी आगे बढ़ते हैं. This also we've already done. Now let's finally create. अभी तक तो on paper only we've made NADH FADH से energy, right? How does NADH FADH actually give you energy? That is via electron transport chain. Again, just like Krebs cycle, this is still we are in the mitochondria only. We have not come out. So this is all happening in the mitochondrial membrane. So this is the mitochondrial membrane. This is the mitochondrial matrix. Okay. Thank you so much. So NADH so basically what is going to happen now? I have these 4 complexes है ना. तो सबसे पहले यहाँ पे ध्यान दो. I have complex 1, I have complex 2, complex 3, complex 4. Complex 1 is for NADH, complex 2 is for FADH. Fine. Baki common hai. Others are common for everything. Okay. So you have complex 3, you have complex 4, you have complex 5. In between complex 1 and 2, you have coenzyme Q, and then you have cytochrome C between complex 3 and 4, and then complex 5 is basically the ATP synthase. समझ में आ रहा है? 1 2 3 4. Between 2 and 3 you have coenzyme Q, and between 3 and 4 you have cytochrome C. Baby stuff, no? All right. So now what is happening basically? It is nothing but an electron transport. So far NADH has an extra electron, right? It has an extra electron which it has to give to form ATP. Okay, so NADH basically gets converted to NAD, and it transfers one electron to coenzyme Q. FADH transfers one electron to coenzyme Q. कोएंजाइम Q देगा कॉम्प्लेक्स 3 को, 3 देगा साइटोक्रोम C को, C देगा 4 को, 4 देगा 5 को. So this is how the electrons are getting transferred. Okay, one thing about cytochrome C that you want to remember, 2 C's are coming here. This has copper as a cofactor. It has copper as a cofactor. Now how does this occur? So there is simultaneously a proton gradient which is also happening. All right, so whenever we have complex 1, for every one NADH molecule, I have 4 H plus which are getting transferred here. From complex 3, how many H plus do I have? Again, I have 4 H plus which are getting transferred, and here from complex 4, I have 2 H pluses which are getting transferred. From complex 2, I have nothing. All right, I have nothing from FADH. So, इससे क्या पता चला? 4, 8 and 2. So these are the 10 H plus atoms which are coming here. All right, so these are the 10 H plus. So for the math basically is that for every 4, I am going to have basically 1 ATP. एक ATP banega for every 4 H plus ions. So this is how 2.5 and 1.5 translates. So when NADH has 10, are you guys getting it? एक ATP, दूसरा ATP, half ATP. So 2.5 ATP from one NADH transfer. On the other hand, FADH is directly coming here. So how many ATPs will form? 1 and 0.5. So 1 and 0.5 ATP. So 1.5 ATP for FADH. So that's the explanation behind the maths. Okay, so this is basically the proton gradient which gets created here in the intermembrane space, that is basically pushing the ATP synthase. All right, that is pushing the ATP synthase. How? So this ATP synthase is like a door. Do you know the rotating doors? धक्का मार मार के आगे चलते हैं. नहीं, याद रखने की कोई इतनी जरूरत नहीं है. Here they only ask you inhibitors. So there is F0 and there is F1. So here you have basically an F0 unit which will open the door, and F1 is basically the ATP synthase where ADP gets converted into ATP. So this door will only open by this H plus. This H plus is pushing the door such that ATP synthase gets activated. So what do you understand from this? ये सारा complicated math से समझ में क्या आया? That if I do not have a proton gradient, can I have ATP synthesis? I can have no ATP synthesis, right? So if I stop the ATP synthesis, but electron transport is still happening, the proton gradient stops, but the electron transfer is happening, will I have any ATP production? अगर proton gradient ही नहीं है, there will be no ATP production. So such agents which will basically block this are called as uncoupling agents. So uncoupling agents do what? ATP synthesis stops, but the electron transport continues because proton gradient has stopped, isn't it? So heat is getting formed, but energy nahi aa raha. Heat is getting formed here. So all of these are basically going to create extra heat in the body. So 2,4-dinitrophenol. So do you agree that this is a good way for weight loss? Yeah, this is a good way for weight loss because you are not creating ATPs, but you are still expending your energy. Right, body में ATP नहीं बन रहा but energy expend हो रहा है. So that's a good method of weight loss. So that is why 2,4-dinitrophenol is used as an uncoupling agent. Yeah, disrupts oxidative phosphorylation. There's no oxidative phosphorylation, but it disrupts the proton pump. It disrupts the proton pump here. All right, that is happening. Okay, so ये है. All right, so 2,4-dinitrophenol. Then we have aspirin. Again, aspirin causes fever after overdose, and thermogenin in brown fat. Because thermogenin has more mitochondria, that is why thermogenin. So this is what you need to remember. Non-shivering thermogenesis. Brown fat also acts by this uncoupling mechanism. I hope you guys understood this. So these are the uncouplers, very important. Then the other inhibitors are very important. Okay, so this is the math which we have done. Other inhibitors कौन है? So just look at these mnemonics. This is more than enough. So complex 1 is rotatone. One आता है नाम में. Rotatone is complex 1. Along with that, you also have metformin, phenorphin. ऐसा कोई भी ins है, rotatone, they are all 1 inhibitors. Complex 3 inhibitors, actin and 3 mycin. So anti-mycin की जगह and 3 mycin याद रख लो, complex 3. बाकी सारे are 4 letters. जिसमें भी 4 letters आता है. Cyanide, carbon monoxide, azides, all of the ones with ides basically with 4 letters inhibit complex 4, and this is what has usually been asked. One of the repeat aims question is all of the following are inhibitors except they give cyanide, carbon monoxide, and they give methane. So remember, methane is not an ETC blocker. Okay, so bas itna yaad rakhna hai. And what does oligomycin do? Yeah, oligomycin was asked. Wonderful. So oligomycin is blocking this enzyme only. It directly blocks ATP synthase. So oligomycin, very important, blocks this, not carbon dioxide, carbon monoxide. Okay, and one extra. What is ADP ATP transfer inhibitor? ADP ATP transfer inhibitor is actractyloside. All right. So transfer naam aata hai, right? So transfer inhibitor. So these are the ones that you want to know. Thank you. Okay. Oxygen is used only here. Yes, only here, right? So this is where you will have oxygen. These H plus ions will react and they will go to form H2O. बस तो इतना याद रखो. बाकी एनी अदर दैट यू get, so I think it's adriamycin नहीं है, यही होगा, antimycin ही होगा. Whatever other inhibitors you get, keep adding to the list. No, that's, I think that you can do. Okay, so this is about the ETC pathway. Mostly you get questions from inhibitors in this. Okay, बाकी सारे जो भी है वो एक बार देख लेना. If you know any others, just add. All right, ठीक है. Okay, so now फटाफट से glycogen and glycogen storage we'll do, है ना, and then we'll stop. Okay, so this we already know. This is the most baby stuff ever. So we again have extra glucose which is lying down. So far, does the vertical pathway of our first aid table make sense? Huh? Everybody, are you with me? So if you are with me, just imagine this in your mind: glycolysis and gluconeogenesis, link reaction, and Krebs cycle. From Krebs cycle, we have interlinks with two things: urea cycle via oxaloacetate, and via propionyl CoA, we have PMS, methyl malonyl CoA, and succinyl CoA gets linked with Krebs cycle, isn't it? Then pyruvate has various fates. Come on, remind me. It can go into acetyl CoA and Krebs cycle. It can form lactate dehydrogenase. It can go back into gluconeogenesis to form oxaloacetate. And what else? Oxaloacetate can go into Krebs cycle also. And what else? It can go into alanine. So one amino acid I have formed from pyruvate. One amino acid let me form from oxaloacetate. Oxaloacetate से क्या amino acid बना सकते हैं? Aspartate. और क्या बना सकते हैं? Aspargine. From ketoglutarate, what can I make? I can make glutamate, I can make glutamine. So you see the interaction between everything. Yes, and then there was one malonate and malonyl CoA which was inhibiting this pathway, which was inhibiting everything, right? So far we have done itna, we've done gluconeogenesis. Now let's go into the other pathway. Yes, thank you so much. So this is where now we're going to glycogen. Now it's all baby stuff. Now we have to do glycogen, we have to do HMP, we have to do galactose and fructose. Yes. So these are the four other pathways which I have to do as far as carbohydrates are concerned. Then I have to do lipids, and then I have to do ketones, and then chota sa urea cycle. And biochemistry is over. So that is what we'll be doing in the next class. I think we'll start this in the next class only because then I won't be able to do glycogen storage diseases. Okay. तो यही करना है. बाकी आर यू गाइस ओके सीइंग मॉलिक्यूलर बायोलॉजी का एमकेटी देख लोगे, बिकॉज आई डोंट वांट टू ऐड दैट बिकॉज वील रादर डू मेटाबॉलिज्म कंप्लीटली. दैट इज very complete in its own sense. I don't think I can make it better, so just see that. Okay. All right, I think 6 hours for biochemistry plus path of molecular biology is worth it. So 4 hours here and then 2 hours there. Okay, we'll finish everything. Amino acids भी कर लेंगे, vitamins भी कर लेंगे. चलो फिर मिलते हैं इन 15 minutes 20 minutes. Just I'll have some food and I'll come back, and I'll try to include MCQs also. Okay. और 5 years भी करना है. One more thing which is remaining, but अब टाइम नहीं लगेगा. Now will be very quick because the concept you have gotten है ना. अब दिल में बायोकेमिस्ट्री बस गया है, अब बस खाली देखना ही है. Okay. All right, so we'll come back. What time? 6:15. 6:15. Okay. विटामिन देख लोगे, हाँ वो फटाफट ही बता दूंगी. जस्ट नाउ विटामिन विल बी लाइक अ रिविजन. कुछ भी नहीं होगा, 2 मिनट में विटामिन हो जाएगा. ओके. ऑल राइट, थैंक यू सो मच, बाय.